Application: Polynomial equations. A4. Draw a graph of a polynomial function that satisfies all the following characteristics. F of minus 3 is 16, f of 3 is 0, f of minus 1 is 0. Y-intercept is 2. F of x is greater than 0 when x is less than 3, and f of x is less than 0 when x is greater than 3. Now, when you have to sketch a polynomial function with given conditions, it is good to make a coordinate system and then do some rough calculations. Okay, so let's try to do that, and this is a very important question. Try to understand how to solve it, right? I have a unique way of doing it, and I hope that will help you to solve such problems. So first thing is just make your coordinate plane with x and y axis. Now that is what we have, and here what is given to us? F of minus 3 is 16. Okay, that means when, let us say this is f of minus 3. So we kind of have a domain in which we are working within minus 3 plus 3. So let's say this is our minus 3 here, right? So let's say this is minus 3. So at this point minus 3, somewhere we have a value 16. So let's put this value here, and that means this is 16 for us. Okay, so I'll write this point as minus 316. Now the second point is at f of 3 we have 0. So f of 3, so let us say this is f of 3 for us, and at f of 3 we have a 0. So that means this point is written as 30. So we have got that point, the second point. Now f of minus 1 is 0. So that gives us, let's say this is 3, this is 2 and 1, this is f of minus 1, which is 0, and let me write this as minus 1. So this is minus 3 for us, and that is 3 for us. Okay, so that takes care of the first bullet. F of minus 3 is 16, f of 3 is 0, and f of minus 1 is 0. Now second, y-intercept is 2. So y-intercept is a point where the graph crosses y-axis. Now that is my y-axis, and let's assume this to be 2. Okay, it may not be to the scale, but anyway it gives you a fairly good idea. It is much lesser than 16. This is 16. Okay, well, sketching graph is kind of making rough calculations, right? So this is my x-axis, and that's my f of x on the y-axis. Correct. Now what else is given to us? Then say f greater than 0. That means function is positive when x is minus 3. That means if you look at this half of the graph, which is on left side, then we have positive. So we have positive here, positive all the way. So this is f of x is greater than 0 when x is less than 3. Well, when x is greater than 3, then the function is negative. So here we are expecting negative. That means the graph will go from here, it will remain above the x-axis, correct? And then it should cross the x-axis from here. Do you understand? So that is how it should be. Now we can connect them in this fashion and finish our graph. Okay, so let's do it. So one of the critical points, so that means the graph turns from here and goes there, correct? So let's connect them, and that's how we connect it. So we are not saying it's maximum here. It can go through the y-intercept and turn from anywhere convenient, right? So like this. So that is one kind of a graph. However, I see one particular mistake here. Well, it's not a mistake when we say fx is, we have already given f3 is 0, so that is fine. So that should be fine. And this is at greater than 3, it is 0, but at minus 1 also it is 0. So let's check whether it works fine or not. So we say minus 3, so all those points which we made are connected, and when f of x is greater than 0, it is greater than 0 when x is on left side of 3, it is, except for these 2 points which are given as zeros to us. So that takes care of this, right? and then on the right side of 3 it is negative. So that is perfect. So that is the sketch of our function. And remember the key things which I made. First thing is plot your points on the graph, and this is kind of critical. Write positive, negative. Imagine this is your rough work area, okay? So don't consider this to be a part of the graph, okay? That is your rough work. You can show all your work here, what you're trying to do. And if you do like this, you should land up with good graphs. Thank you.